Hello, hopefully at this point you have your quiz in front of you. There were two versions, the B version and the C version. So I will go over both of those. One time I will go over them using the reverse tabular method, and the other time I'll go through them using long division. Even if you didn't have the particular version that we're looking at, this should be quick enough that you should be able to see what maybe your neighbor did. These are great example problems to look through and might be helpful as you start doing your activity today. So if I'm going to use division to find this quotient, the first thing I'm going to need to realize is that right in here, we have a missing term. We need the 0x term in there. And so I'm going to start by doing the reverse tabular method. It's something that I particularly prefer. It turns out that when we do this, we need a 3 by 2. Okay, 3 by 2. We've got our 4x squared, our 0x, and our 3. And then here in the diagonals, we've got our 12x to the third, 4x squared, 9x, and 3. And I start with this top right corner, so the 12x to the third power, and then I know that 3x times 4x squared gave me 12x, and I fill down the rest of the row, so it's a 0x squared and a 9x. Great, that means that this upper right-hand corner here has got to be 4x, because this plus this has to be 4x squared. So we've got a 4x squared, which means that this has to be 1, because 1 times 4x squared is 4x squared. That's 0x, which is good because 0x plus 9x is 9x. Okay, and then 1 times 3, here's our checkbox. We've got a 3. And so my answer to this problem, I was looking for 3x plus 1. Somehow you needed to have that plus sign between the 3x and the 1. So I'm going to redo this same problem, except for this time I'm going to do long division, but I'm also going to add that 0x in there. So the first thing I need to do if I'm going to do a long division problem is I'm going to need to rewrite it. So I'm going to rewrite 4x squared plus 0x plus 3 divided, and what are we dividing? We're dividing 12x to the third power plus 4x squared plus 9x plus 3. So again, we think something times 4x squared is going to give us that 12x to the third. That's got to be a 3x. 3x times 4x squared is 12x. 3x times 0x is 0x squared. And 3x times 3 is 9x. Okay, so I subtract everything. So 12x cubed minus 12x cubed is 0. 4x squared minus 0 is 4x squared. 9x minus 9x is 0. And I bring down my next term, which is 3. Changing colors for your help. I need something up here multiplied by 4x squared plus 3 to be 4x squared plus 3. Oh, hey, look, that's 1. 1 times that stuff gives me the same thing. 1 times 4x squared, 4x squared. 1 times 0x, 0x. Oh, that should be an x there as well. 1 times 3, 3. When I subtract, everything subtracts. 0, 0, 0. And I'm left with no remainder. So the answer to this division problem is 3x plus 1. It's the same as the previous one. It's just using long division versus the reverse tabular method. So this is for version C. I'm going to use the same ideas applied here. There was still a 0x that was missing, and we still need a 3 by 2 division problem. So And these are just really big squares. I don't know why I did that. 3x squared, 0x, and 2. Out on the side, we've got that 6x to the third, 12x squared, 4x, and 8. I always like to start over here with the 6x to the third. Something times 3x squared is 6x to the third. That's got to be 2x. 2x times 3x squared is 6x cubed. And then we fill down. Oops, excuse me, that's a 0x squared. 2 times 2 is 4, so 4x. I can do this top one. 0 times 0, 0x squared plus something is 12x squared. That's got to be 12x squared. 12x squared, which means that this has got to be 4, 0x, and my check is my 8. Perfect. So the answer to this division problem, 2x plus 4. Last but not least, I want to redo this division problem with the long division method. Same ideas here. I still have that 0x, so I've got 3x squared plus 0x plus 2 is the thing I'm dividing with, and then the thing I'm dividing goes underneath, 6x to the third, 12x squared, 4x, and 8. I think something times 3x squared gives me 6x to the third. It's got to be a 2x. 2x times 3x squared, 6x to the third. 2x times 0x, 0x squared. 2x times 2, 4x. I'm subtracting. I've got 0. 12x squared minus 0x squared, 12x squared. 4x minus 4x is 0x. Okay, and bring the next term down, which is 8. I'm going to switch colors for us. I think something up here, something multiplied by 3x squared gives me 12x squared. 3 times something is 12. 3 times 4 is 12. Okay, I'm going to have to put 4 up there. So 4, so it's a positive 4. 4 times 3x squared is 12x squared. 4 times 0 is 0x. And 4 times 2 is 8. When I subtract, I get 0, 0, 0. The solution to this is 2x plus 4. So many of you were curious about the solution to this question. I figured I'd be happy to share it with you. It's actually quite interesting. I'm going to be trying to be very methodical about how I approach it. But the first thing to realize is that there is one giant square. I'm going to call that a 4x4 square because there are 4 little segments to it. So I'm going to call that a 4x4 square. A 4x4 square. And there's just one of them. Okay, so there's a 4x4 square. And then I'll start next by doing 3x3 squares. So 1, 2, 3. By 3, there's 1. There's 2, 3, and 4. So there are a total of 4 3x3 squares. There's 4 of those. And then when I go look at 2x2 squares, there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 9 2x2. 2x2. There are 2 of them. 2x2. There are 9 of them. Excuse me. And then if I count all of just the small boxes, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 1 by 1s, and so I will write 16 of those. And then I think about my inner squares. So when I go to do my inner squares, I'm thinking of these little guys on the inside. So if I think about the 2 by 2 inner squares, then I have the 2 by 2 inner squares. There are 2 of them. There are 2 of those 2 by 2 inner squares. Wow, my iPad is just not doing well with this. There are 2 of them, and when I think about the little ones inside, the 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of those 1 by 1 squares. 1 by 1. There are 8 of them. There are 8 of them, and so I think, okay, there is 10 there. There is 9 and 1 is 10. And 4 and 16 is 20. So overall there are a total of 40 squares in this picture.